Good morning, everybody. Welcome back to another stream comparing C and C++ on the ESP32. On today's stream, I'm going to be comparing object-oriented programming. And now, before you say, "Oh, but Kevin, C is not an object-oriented programming language. Only C++ is," I disagree. And actually, I would have agreed with you several years ago until I read a book by Bob Martin, Uncle Bob, as he's known sometimes, in which he makes a super compelling argument that object-oriented programming means nothing more than dealing in a concept of objects, which you can totally do in C. It's just a different syntax. And so I have a sort of contrived example in my head. We'll see how easily it comes out of my head and gets onto the into VS Code. But we'll do that in C and then C++, compile them and compare them the way we have in previous episodes. Before we do, however, I want to give a brief update on something that I realized we weren't doing in the test before. Luckily, we haven't done too many of these episodes yet, which is I was not choosing the optimized compiler settings when comparing the two of these. And we do that in our CMake list. Somebody in the YouTube comments pointed that out, which let me, I want to give him a direct call out. I don't remember his handle, but let's see. YouTube Studio. Ben, I want to say it was Ben. Oh, let's get it for real. Okay. Ben. Ben William. I appreciate him pointing this out. I had thought about this, but he called it out specifically and had asked about certain compiler flags to make the difference between C and C++ even smaller. And so I did look at this. The one that I'm most focusing on here is this -OS that optimizes the binary for size. The IDF doesn't support the full range of -O flags, um, which that almost looks like a 0. No, it's definitely no. Okay. There we go. So I added that. He had also recommended a few other settings, which I also played with, which is this no exceptions, no RTTI, data sections, function sections. I added all of those. They made no additional difference. So I'm guessing maybe the IDF already includes those. The OS, however, did make a small difference in our thread example of about 200 bytes smaller on the C++ side than without the OS compile flag. So he had also recommended trying this LTO, which is link time optimization. That was something I learned about, I wasn't aware of. When I enabled that, you can see I have it commented out. It actually didn't compile, and so that made some of the IDF core libraries upset for some reason. I didn't dig into that anymore, but it did not compile with LFTO. And so I'm actually going to just, well, I'll leave the rest of these in here just for to be explicit. I'm going to get rid of this one. So yeah, so now we're compiling with OS. I believe that's as small as we can get the C++ compared to C. But if anybody has any other compiler options they'd like me to try on this, just stick them in the comments. I'd be more than happy to compare those as we're going through this. So, okay, I'm going to save that. Let's get into our examples. So I'm going to go ahead first of all and comment out our run thread test because we're not doing that anymore. And just to make sure we're, let's see, printf. Well, no, let's not do that yet. I want to make sure we're back to a baseline. I've already created a new component here called OOP, Object-Oriented Programming. And I've got the C source and the C++ source. So let's open that up. That's the C source. C++ source. Open it. Okay. Oh, and I still have all the thread code in here. Let's clean this all up. OP test. Okay, and let's just do the print and just a quick test to make sure that we're about the same size. So I'm going to come back over here to main. I'm going to include op test c.h over here. And then I'm going to run op test. And on this side, I'm going to do the same thing. I'll include the CPP header and run. It's not finding that, which means I probably run OP test. Yeah, it's there. Okay, I'm not sure why IntelliSense didn't try to help me out. Okay, and then let's just make sure. I want to make sure our difference is, I believe at this point should be 0. So they should be exactly the same size because there's just a printf. I'm hoping. And that way we have a good comparison between when we write our example program in C versus C++ to do the same thing, that we're really comparing the sizes appropriately. So let's do that. Give fair warning, my C is rusty. I've prepared a little bit for this, but this could be a mess of me trying to go through and like I said, get this concept out of my head into C code. Okay, let's look at the results here. The diff. Difference is 0. Okay, so, and again, well, I can't really make this bigger, but it's just comparing the C++ map and the C map, and it does current minus reference, current being the C++. And so you can see up here the difference is +0, and there's nothing in the difference column here, which means at this point, as compiled, our C and C++ programs are exactly the same size in Flash and DRAM and all that other stuff. So that's exactly what we want before we start writing any code. We're at a fresh, clean comparison. Okay, so let's also open up the H file over here. So the contrived example I came up with is a sensor. Now, I can already hear the comments that are going to go to this, but I'm going to do this to try and do a direct compare. We're going to, you know what? Let's just do it. Let's get into it. So I'm going to have, when I say, I hear a lot of people say C is not an object-oriented programming language. They think too much in terms of C++ having classes. A class is not necessarily an object. And the argument that really sold me on this is if I just do a type def struct and then give it, you know, a member and then a name, we're going to call this a sensor type. That's an object. And if I create a sensor type variable over in my C file, it's an object. It represents an object being nothing more than an abstraction of something that exists, you know, in a different domain. Typically, we call that the real world. And so C is very much can be an object-oriented programming language if you're dealing in a concept of objects. Now, it doesn't have the language construct of classes, but that doesn't make it not an object-oriented programming language, which you can agree or disagree with that, but that's where we're at. I consider a sensor in this case an object that I'm going to deal with in code. Now again, because it's C, I have to do that a little differently than I would in C++. So let's compare that. So as a sensor, I'm going to say it has an address. And what I mean by that is like, again, this is a completely contrived example of like an I2C sensor where it has a bus address or something that we may want to set. Let's see, the other things that I said we would give this are char star name. because it has a sensor name, so it's not just simple integer types. We're going to give it a float. We'll do a double, actually. A double reading that we just pull off of it. And now to make it just a little bit more involved, we're going to give it some enum values here. So we're going to say type, I think this is right, type def enum. And we're going to call it sensor temp equals 0 and sensor humidity. And this will be the sensor type enum. And then we're going to do a type def enum single shot. And if you're not familiar with this, a lot of sensors will have what's called a single shot mode. Continuous. No, did I do that? Yeah. A single shot mode where you ask it for a single reading, or a continuous mode where it will itself gather readings every interval, and then you can query that from the sensor. So that's just a common sensor thing, single shot versus continuous. And we'll call this the sensor mode. Okay, so the other things that our sensor will have will be a sensor type, and a sensor mode. Great. Okay, so I think that's good. And then we need to give our object some functions to work with. Now, again, this is where the object-oriented version of this comes in. Obviously, sensor T itself, we don't have functions on, although you can in C++. In C, a common pattern that you'll see all over the embedded world is to have something like a void, and it might not be void, it might have an error return code. I'm trying to keep the example a little simple here so we don't get crazy. Sensor init. And then oftentimes you'll see something like this, like a config pointer. Ooh. A config pointer is passed. So you'll have like a config object which specifies all of the things that you can configure on a sensor, and it will assign it to it will return the struct to you. So what we'll do is you'll often see it passed in. So it'll be something like this. It'll be sensor type pointer sensor. So the sensor that you want to initialize. And then what we're going to do is just pass them all in as the init will be like our constructor. So we'll say the address will pass in here. Let's try name. You wouldn't pass in current reading. That's not something you would initialize a sensor with. And then we'll say sensor type, and sensor, mode. And just to make this a little more friendly to read, we'll do this. Okay. I think that all looks good. This would also be, so there's a couple ways we could do this. We could do, this should be constant char star. We could do that where the calling program is responsible for the memory, or we could store it. Let's do that. So let's change this a little bit and say that the name can be anywhere up to 32 characters. And then you would pass in a const char star name on the constructor, and then we'll store it on the struct itself. Okay. Sensor init. Let's see. Let's do a void sensor set mode, where again, this is just a pattern you'll see. You'll pass in the sensor, and then you'll also say sensor mode, void sensor get mode. Yeah, I know. And I can hear you already. Well, why wouldn't you just access it directly? Bear with me. There's, imagine there's some more complicated thing happening with setting the mode where, for example, like on an I2C device, you're not just setting a member on the struct. You may need to do some I/O to actually set the mode on the chip. So in our example, it'll be very simple, and you'd say, why not just access mode and directly? But just imagine, like I said, there's some actual chip communication going there. Sensor, and I'll call that out when we get there. Sensor get mode of the sensor. Yep. Okay, and then obviously the big one is, we'll say double sensor get reading. And again, we'll say sensor type T sensor. And that's it. Okay, I think that's everything. What I'm going to do is I'm going to grab this and slide it over to this window so that in our source file, we can implement these things. Okay. So the first thing we're going to do is we're going to say void sensor init. And we need all that same, let's just grab it. Like this. Will pound include op test c.h. Okay. And then in here, what are we going to do? We're going to say on the sensor, say sensor address equals address. And again, just want to make sure I'm heading this off. I know I can hear you saying, why wouldn't you just in your main do a sensor and then do access address there and set it to an address and this and that? Again, this is just a pattern that you'll see. It's very common because, again, some other things may be happening here. Like here, I'll show you that in a second. We'll say, so we got the address. Let's do sensor type equals type. Sensor mode equals mode. And then we'll do like a stir copy sensor name name. Yeah. Okay. And then it's like in the real world, do device IO here. Connect over I2C or SPI. So there's some other thing that you're doing here as part of the constructor of the device. Okay. All right, so that's our constructor in C. And then we'll come down here and we'll say void sensor set mode, sensor type, sensor mode, and we'll say sensor mode equals mode. Okay, like that. Oh, and it wouldn't be a void on get mode, right? It would be a sensor mode. Okay, so say sensor mode, sensor get mode, right? Sensor. You know what we're not using right now, which I have access to? Let's do it real quick. I don't mean for this to be like an advertisement for Copilot, but I've been test running Copilot to see how it is. And it's actually really great for stuff like this. It would save me a lot of keystrokes here. Yeah, see, like it just IntelliSenses immediately to the code that I would write. So that's gonna speed up our video here. Okay, and then finally, double sensor get reading. See, and so this is again, Copilot will just suggest all this. Sometimes it's good. Yeah, and so check this out. I really, again, I guess this is like an ad for Copilot in some senses. It even gets the comment here that I would have typed. In the real world, actually get the device reading with I/O over I/O. Close enough. I'm gonna hit tab, accept all that suggestion. Say over I/O, which I will change this to as well. Okay. So we're gonna get the current reading, and then for the sake of the demo here, let's just say sensor current reading equals some number like 123.4. That's going to kind of taint our experiment a little bit because the compiler's going to see that and do some optimizations for us, but it should do that on both C and C++. I would introduce random number here, but then that's going to also taint the experiment because getting a random number in C versus C++ is probably going to have different results. So we'll just try this for now. And then in our run test, what should we do? Well, let's see what GitHub thinks. Sensor init temperature sensor, and it gives an address. Cool. Let's just take that whole suggestion. It's a sensor temp. It's a single shot, and we're gonna print sensor name. Oh, you know what we could do? We can do sensor name n, and then we'll do sensor address. Yes, just like that. And then we'll do sensor type. Yep. And then we'll do sensor, what's it suggesting? Sensor mode. Cool. And then sensor reading. That way we're making sure we're using all of name, address, sensor type, sensor mode, and then sensor get reading. Let's do no. Let's do this actually. Let's do sensor reading. Sensor name, address, reading. Sensor get reading. I think that's all right. And then we'll do something like that, just to make it a little more. Yes. Let's do that. Break. Case continuous. Go GitHub. Continuous. Okay. Great. Yeah, default, we'll just say sensor mode unknown. Yeah, that's great. And then close out our switch statement. Okay. So we're going to say print sensor name. I got another idea. Void print sensor info. We're going to do sensor type sensors. Can I do that in C? And do like a for int I equals 0, I less than size of sensors. And then take all of this, put it up here. Oops. It doesn't. Yeah, and then I would say like sensors I. Does that work? It doesn't like it. A structured unit type has a type sensor type pointer. Oh, yeah, but that's okay. I knew this example was going to get out of control. What's it not liking? Applied to sensor type. Well, this is where my C is going to fail me. I thought you could pass. Just ask Google. That might just be a C++ thing. Yeah, that should work. Array, yeah. And then we say operator applied to sensor type instead of, well, yeah, because it's not a, it would be like that, but then it didn't like that either. Okay. Address sensors I. Okay. And then sensors I, great. Battery. Okay, and then one last thing. Oh, jeez. Definitely should have prepared this ahead of time. Okay. Bear with me. Okay, switch 4, and then we have to close out the 4. Okay, so we're printing sensor info, and then now let's do a sensor type, a humidity sensor. And yeah, see, like Copilot made, I was going to make it continuous as well. So like scary how good it is. It gives it a different address and everything. And then we'll say something like that. And then print sensor. Oh, yeah. Full clean. C version. Which one? I built. Let's just see if this builds first of all. Again, on all these, I'm just using a dev kit C to test that it's working correctly. Okay, yeah, it's not liking that. W air size, sensors will return size of sensor type pointer. Yeah, so a common thing you'll see actually is, where did my print? We'll just do this. Yeah, int num sensors. We'll just do that. Okay. Stir copy. Oh, it doesn't know about it. So we need to found include C string. Or, oh, is it it's just, in C, it's just string. I think that's right. What? Help me out. Oh, string.h. There we go. There we go. Copilot knew. It's funny. Copilot is great sometimes. It's awful at other times. Like completely wrong suggestions, even with the context of my code. So it's hit or miss. Let's do an IDF.py flash monitor and just see what this thing spits out. Okay, cool. Temperature sensor, the address, the reading, humidity sensor, the address, the reading, and the mode. Okay, that's really all we were going for. Okay. And again, I don't know how much the compiler is going to optimize here, especially for size. But, I mean, it's going to do it for C++ as well. So that's our program. Now let's recreate it in C++. Hopefully that'll go a little bit faster. So let's open the header over here. Okay, so all of these things have equivalents in C++. So we're going to say enum class sensor type. So you see, like, immediately Copilot was suggesting color. And then, okay, yeah, here's another, here's an example. And it's what I don't like about GitHub Copilot is look at this giant block that it's suggesting. It's a, as far as I know, and I haven't looked, but it's a take it or leave all of it. So I can either hit tab to take all of that, but if I'm like, oh, just a few of these things are actually what I'm looking for, there's no really clean way to do that as far as I'm aware. So we're gonna do this sensor temp, and then now it's like, oh, what about humidity? So it kind of it gets there. Okay, great. And now we're going to do enum class sensor mode. And again, it's not getting the modes correctly. So we'll say single shot. And then it should pick up on continuous. There it goes. Great. So that's the equivalent of that. And now we don't do a struct. We can do a struct, but we'll do a class sensor, right? And in our class, Yeah, that's close, but no. We're going to have sensor where we're going to take in an int address. Now, you're going to see I'm going to do const char star name here. Now you might say, well, why aren't you doing standard string? Standard string and const char star create their own very different compilation sizes between C and C++. And so I'll do a whole separate episode on const char star versus standard string. They're completely different animals that I don't want to taint this test with that difference, because you'll see a massive increase. I mean, massive. I don't know. We'll find out when we do the episode. But you'll see an increase with using standard string that I don't want to introduce right now. So we're going to stick with const char star. One of the great things about C++ is you can use const char star if you want to. So we'll pass the name in. We need the sensor type and the sensor mode. I think it got all the rest of that correctly. And then in, let's do this again so you can see it. Address. In C++, we can do some cool things where we say, let's see, I think we should be able to put that down here and then do, we can set some of these things. And I don't love that it's called m address name type and mode. So we'll start with that. And then what you would do down here is you'd have a private. Let's see if it creates the same suggestions. It kind of does. Okay. Okay, so I've got m address, const char star. No, we're not going to do const char star because we're going to store it, remember, the same way. We don't want to add any new const char star, sorry, char m name. We need a double, we'll do m current reading. We have an m type and an m mode. Okay, and then I don't know how much of a difference it makes in C, but in C++, for class size at runtime, there's an optimization where if you sort these by their size, it compresses the total size of the object. And so what we would want to do is put these in an order like this, which then means you want to initialize them in that order. So we're going to say the current reading, we're just going to set to 0. We'll do the, I believe we can just do something like this. Like right in the constructor. Like that, yep. And then we'll do the sensor type, the mode, and then the address last. Okay, I believe, does it say it doesn't like that? Yeah, it's probably not liking that. Okay. And then in the constructor, we'll just go. Oh, you know what? Actually, it probably was fine with it. We just need the header. Include string. Yeah, is it still not liking it? Is a non-static base class. Yeah. Oh, yeah. It's thinking it's a type. Okay, cool. That's fine. Okay, I think we're all set there. Do I need a on there? What's it hating? Expected and expression. Public sensor. It takes all these arguments. We're going to set these. Oh. There we go. Okay, so that's our C++ equivalent constructor for our sensor type. Let me just review this real quick. Address, char star name. Let's look at the c.h. We are looking at the c.h. So in our init, we're passing, we don't have to pass the sensor because in C++ that is the object that we're working with the class. We pass the address, the name, the sensor type, and the mode. So address, name, sensor type, and mode. And then we're going to set all those on our sensor. And then we also need the public interface, which we can almost just copy from over here. We're going to put that under the public side of things. And so sensor, we're just going to do a set mode. We don't have to pass the object this time, and we can change this to sensor mode. And same thing here. Here's that sensor mode, and we'll just call it get mode. And we can get rid of all of this. And double get reading. And we can get rid of all of this as well. We don't have to pass that. So that's our interface. And I think that's everything we need in our header. So let's save that. So that's our C++ header. We're going to drag that over here and pull our C++ over here. No, actually, I like it the way I had it. Okay, and now what I want to see is the source C, because we're going to basically do the exact same thing over here. So in our source, we're going to pound include that. And now we need to implement. So we already have the constructor. And so that whole sensor init doesn't need to happen. But for completeness sake, back over here where we do our constructor, let's put our little comment in the real world. Do device IO to initialize the sensor. Great. So there'd be some other thing that we're doing there. And then let's come back over to here. So we've got our init is done, and now we just need to implement the other things. So we'd have our sensor, it's sensor mode, get mode, and we'd return the mode. And then we've got void sensor set mode, where we're going to set the mode. And then again, in the real world, we need to actually communicate with the device to set its mode. So again, that's why the example's a little contrived, but we would do things like that here, like talk over I2C or SPI. And then what do we have? Double sensor get reading. I'm reading, and then we're going to do the exact same thing here to make sure it's the same, which is we're going to say m current reading, and we're going to set it to the exact same just to make sure there's no difference between them. And then we need a little helper function here that's called void print sensor info. Sensors. Yeah, and we'll do it the exact same way. And then let's just actually grab, just to make sure we're doing this head to head. I less than num sensors, print sensor name, and now Now we wouldn't have name isn't. So here's the difference. Name is not public the way that we have this. It's not a public member. Now we could make it, right? So I guess to make this the same, we could make our name that. I don't. So the idea in C++ is you'd want to make some of these private and some public. And C in a struct, all members of a struct are public by default. And so we could do this, or we could add a get name to return it. Let's just do this for now to kind of keep our comparison close, even though it's not, I don't know. I mean, it's not really how you do it, right? Mname. Same thing here. Address, we wouldn't really make public because once you set it in the constructor, you wouldn't want it to. You know what? We're doing it. We're going to make it so that we're going to do it the right way. And so what we would do here is we'd have an int get address, return address. We'd have a const char star get name. And the same thing, we'd have the for type, and we already have mode. Yeah. Oh, not const char star. It'd be sensor type get type. Okay. I'm hobbling C++ here. But it's okay. But what we can do is let's inline these. Oh, my comparison's getting a little out of line here. But let's just see where it lands. I mean, because there's optimizations we can do. So I'm not worried about it. Get address, get name, get type. And so over here, we instead of accessing them directly, we would say get name, get address. Since we just call get reading. Sensors I dot get reading. And then we'd say sensors I get type. Okay. And then here we'd say sensor type. I believe is how that would work. Sensor type. Continuous. Okay. I think we're almost there. It's not liking my printf. Do I ever close my printf? No. There we go. Let's look at our source, print sensor info. And then in the test itself, we're going to do what? We're going to say sensors, temp sensor, which is a single shot, a humidity, which is continuous, and then let's take all of GitHub Copilot suggestions. Yeah, this is a way we could do this. The size of sensors divided by the size of a sensor. We'll just do 2 to keep it the same as in the C. And I don't know, I'll save it builds. We'll clean. CPP version equals 1. Build. Let's see. feel like it never builds the first time, but let's see where we end up. What's it hating? No OOP test CPPH. What? Oh. There we go. Single shot. Did I name them different? Sensor mode, single shot. Oh, this isn't get type, this is get mode. Continuous is not. I'm switching get mode, which returns a sensor mode. Oh, sensor. Yeah, okay. Sorry. Okay, now let's flash it and see if we get the same output. Pi flash monitor. Okay, that looks great. Address. The addresses are a little different than in the C program. 12 and 34 versus whatever it was over here, 48 and 49. This is actually an important difference. So this should be temperature sensor. So that way the strings and stuff, that's going to affect our size. And let's just make them the same addresses for kicks. Okay. All right. That's what we're looking for. Now it's time to run experiment. And again, I didn't prep as much for this as I should have, but there's some things that we would do differently, we could do differently to optimize. But let's just see, based on that raw mess that I just spewed everywhere, where we actually end up using classes in C++ versus structs. I probably should have started with a simpler example of like a single struct and then just doing something with it and then make it a class in C++. I think you would see a 0 difference. In this case, we're probably going to see a difference. That we might not otherwise see. In other words, I think I may have tainted the experiment quite a bit, but let's just see where we're at. Look at that. That is not what I would have expected at all. The C++ program, as you can see, the current is C++, the reference is C, and so the difference is current minus reference. And so a negative number, it says right here, i.e. a positive number means that current is larger. A positive number means the C++ is larger. A negative number means the C++ program is actually smaller than the equivalent C program in this case, which actually shocks me. That is not what I was expecting at all. Wow. Okay. Well, that was a fun experiment. So completely equivalent output. And again, there's lots of things you could nitpick about this, but I feel like I tried to stick pretty close to patterns, right? Again, you might say, well, why are you doing set mode here instead of just calling the object's mode and setting it? Again, I didn't make the patterns. I just follow them. Like this is, you'll see this all throughout. If you ever look through the IDF code, like you'll see this everywhere in C where you pass in the struct as the object and then do something with it or set something. And again, there would be other things going on here. So Um, I still haven't put this repo up on GitHub. I will do that so that you can, follow along at home. But cool. That is super interesting. I wonder if that's just compiler optimizations that are happening. But anyway, I'd love to hear your thoughts on this after seeing this, comparing it side to side. Like, you can tell me what I did completely wrong or screwed up or wasn't fair to see about or did wrong in C++. I welcome it all. Um, Again, not the result I was thinking. I thought it would be close, but I thought it would be in C's favor. In fact, C++ ended up being the smaller binary in this case. So anyway, that's going to do it for this episode. I think, I don't know if it'll be next episode, but soon I'll do the string comparison. We'll do const char star versus standard string and show you the differences there. That one's a little harder because there's going to be a compile time difference, of course, but also runtime is very different between the two. With const char star, the way that a lot of that works, it can be in the main binary, whereas standard string always allocates. It always uses the heap. And so there's some runtime differences there that we wouldn't really capture with our diff script here that we're running against the map files. But we'll play around with that a little bit so we can see the difference between the two. But anyway, thanks so much for watching. I really appreciate it. Again, comments below on what you think about the experiment and ways that I could make it better. Happy to receive that feedback. Otherwise, have an amazing rest of your day and week, and we'll catch you next time.